NASA has observed interstellar objects entering the solar system for the first time. The galactic visitors could offer clues about the formation of the universe, and maybe even hold clues about intelligent life in the cosmos. Let's take a closer look. NASA estimates that there are more than 300 million worlds with similar conditions to Earth scattered throughout the Milky Way galaxy. A new analysis concludes that roughly half of the galaxy's sun-like stars host rocky worlds and habitable zones where liquid water could pool or flow over the planet's surfaces. The finding, which has been accepted for publication in the Astronomical Journal, pins down a crucial number in the Drake equation. Devised by Frank Drake in 1961, the equation sets up a framework for calculating the number of detectable civilizations in the Milky Way. Now, the first few variables in the formula, including the rate of sun-like star formation, the fraction of those stars with planets, and the number of habitable worlds per stellar system, are known. The astronomers estimated the number of these planets using data from NASA's planet-hunting Kepler spacecraft. For 9 years, Kepler stared at the stars and watched for the brief twinkles produced when orbiting planets blot out a portion of their star's light. By the end of its mission in 2018, Kepler had spotted some 2,800 exoplanets, many of them nothing like the worlds orbiting our Sun. But Kepler's primary goal was always to determine how common planets like Earth are. The calculation required help from the European Space Agency's Gaia spacecraft, which monitors stars across the galaxy. With Gaia's observations in hand, scientists were finally able to determine that the Milky Way is populated by hundreds of millions of Earth-sized planets orbiting sun-like stars, and that the nearest one is probably within 20 light-years of the solar system. In its original form, the equation assumes that technologically savvy aliens would evolve on planets orbiting sun-like stars. It took more than half a century for scientists to start pinning down how many planets could feasibly host life. In 1961, astronomers knew of no worlds orbiting stars other than the Sun, and although planetary formation theory suggested exoplanets should be common, we had no observational evidence that they existed. But over the past decade, it's become clear that planets are extremely common, outnumbering stars in the Milky Way. On average, nearly every star is home to at least one orbiting world. Kepler spots faraway worlds by looking for dips in light produced as planets cross stars' faces and briefly blot out a fraction of starlight. Based on how much starlight is blocked and how often, scientists can figure out how big a planet is and how long it takes to orbit its star. Using this approach, Kepler spotted thousands of exoplanets of all sizes and orbits. But scientists' real quest was for the fraction of planets like Earth: temperate, rocky, and orbiting sun-like stars. Early estimates suggested that perhaps 20% of sun-like stars hosted a world that met those criteria. We now know that the number is closer to 50%. If not more. Instead of basing a planet's potential habitability only on its distance from a star, the team calculated how much energy is reaching each of these worlds. From there, the team selected the worlds where temperatures would allow liquid water to survive on the surface. Once the team had a sample size of known rocky temperate worlds orbiting sun-like stars, they were able to estimate how many exist across the entire galaxy. They found that between 37 and 60% of sun-like stars in the Milky Way should host a temperate, Earth-sized world. And using a more liberal calculation of the energy needed for a world to be temperate, they found that as many as 58 to 88% of sun-like stars could have such a world. Now that astronomers have a good sense of how many worlds similar to Earth are strewn across the galaxy, they can continue working through the variables in the Drake equation. Many of the remaining factors will be tough to pin down, including the crucial questions of how often extraterrestrials develop technologies that we could detect, and the length of time such civilizations are detectable. Astronomers are tantalizingly close to figuring out the next factor in the equation, the fraction of habitable worlds on which life evolves. As we continue to explore our solar system, we are finding out that the list of habitable niches is long and diverse. Finding just one example of life beyond Earth would demonstrate that biology is not a cosmic fluke, but rather a probable outcome, given the right ingredients. And considering the amount of habitable real estate in the cosmos, many astronomers say that life is an inevitability. A strange interstellar object entering our solar system was discovered by accident in October of 2017 by Robert Weirich, a postdoctoral researcher at the University of Hawaii's Institute for Astronomy. While scanning the skies above Maui for asteroids approaching Earth, he thought he had found what he was looking for, but upon closer inspection, it was determined that the orbit of the object did not make sense. After performing numerous calculations, it was found that the trajectory of the object was consistent with it originating from outside our solar system. This came as a major surprise, as many in the astronomical community had been seeking such a visitor for decades. Up until its arrival, no interstellar object was known to pass through our neighborhood before. Since it was first discovered at a facility in Hawaii, it was agreed that the object would have a Hawaiian name. Upon discussing what the object was and how it was found, the name Oumuamua was proposed. The word translates to it being called the first scout from a distant place. The shape of the object is one of its strangest properties. It has been compared to looking like a cigar floating through space. While it passed too far from Earth to appear as anything more than a dot, even through the most powerful telescopes, the way its light brightened and dimmed indicated that it has a stretched out shape. It is estimated to be at least 7 times as long as it is wide, but it is quite smaller than initially thought, as it is no bigger than 3,000 feet by 400 feet. Additionally, the object has been observed to tumble as it travels, completing one full flip about every 8 hours. While there are many realistic-looking illustrations of the object, astronomers are not yet certain about what it looks like up close. Oumuamua is also thought to have a reddish surface, but this is also yet to be confirmed. Its color seems consistent with other comets that are made of ice and rock. Additionally, the object sped up after it passed the sun, and this is likely because it was pushed by the outgassing of frozen material from its surface, a common characteristic among comets. However, upon observations by NASA's Spitzer Space Telescope, no evidence of a comet-like tail of gas and dust was found, leaving scientists perplexed. Oumuamua slingshot past the sun at blistering speeds of 196,000 miles per hour, and its trajectory suggests that it had been wandering through the Milky Way, unattached to any star system, for hundreds of millions of years before finally entering our neighborhood. The existence of such objects was theorized for decades, but this was the first time one could be observed so closely. Immediately after its discovery, telescopes around the world, including ESO's Very Large Telescope in Chile, began to measure and observe its path, orbit, brightness, and color. Combining the images from the ESO telescope using 4 different filters with other large telescopes, astronomers found that the Oumuamua varies in brightness by a factor of 10 as it spins on its axis every 7.3 hours. This is very interesting, as no other known comet or asteroid in our solar system varies so widely in brightness, and with such a large ratio between length and width. The reddish color of its surface also suggests that, similarly to other objects in the outer solar system, Oumuamua is completely inert. This means that the object is very dense and composed of rock and possibly even metals. It has no ice or water, and it turned red due to the effects of irradiation from cosmic rays over hundreds of millions of years. The massive telescopes continued tracking Oumuamua as it receded from our planet and started to fade into the distance. It was observed to be traveling at 85,700 miles per hour relative to the Sun. Its outbound path was about 20 degrees above the plane of planets that orbit the Sun. It passed the orbit of Mars first, and then traveled beyond the orbit of Saturn in 2019 as it left our solar system and headed for its next destination, which seems to be the constellation Pegasus. The strange characteristics of the object made it look like a spacecraft that came from another star, took a quick pass through our system, and then sped away. Many astronomers have been intrigued by this possibility, and the researchers at the Search of Extraterrestrial Intelligence listened for any potential technological signals leaking from the object on 2 different occasions, but came up empty. One popular theory came from Avi Loeb of the Harvard-Smithsonian Center for Astrophysics that stated that Oumuamua was an advanced piece of alien technology that uses a light sail method of propulsion. This type of propulsion is thought to use the sun's photons as a means to power the craft. His reasoning for this is that if the object was a comet, its outgassing would have altered its rotation period. This effect should have been easily identifiable on the Oumuamua, but was never observed. Loeb believes that the object could be a defunct piece of space junk from an advanced technological civilization that accidentally landed in our system. Another theory is that it could potentially be an exploratory ship that was sent to check out our region in the universe. While very few scientists agree with Loeb's views, he contends that dismissing the possibility of aliens eliminates useful hypotheses that should be an acceptable part of rational inquiry. Loeb has made it clear that he does not claim that the craft is alien, only that the scientific community is open to the possibility that it could be. Currently, there is no concrete evidence that links Oumuamua to an advanced alien race, other than a few considerable theories about its origin. A lack of data on the object has made it difficult to properly identify where it could have come from. If you like this video, you may also enjoy this one, which talks about Voyager 1's contact with an unknown object in space. Do you think there will be more interstellar visitors in the future? Please share your thoughts in the comments section below.